Good day, YouTube. It is the 24th of October, 2023. This is going to be an interesting video. I've been kind of excited about making this. I've been thinking about it for a long time. I've been up since 3 o'clock this morning thinking about how to put this together. And then let's just start this thing rolling and let's just get into it right now. This is 4 of my Honda generators. It's actually 4 of the 16 Honda generators that I own. It's a little overkill, I get that. I am a collector and a hoarder, but all my generators have stories, and I certainly didn't buy all these new. Let's just quick overview. EM400 from the 70s on your left, this here. Probably 1975, 76, somewhere in there. I maybe even a little early, 74 possibly. I had a green one, EM400, years ago. I believe it was a 72 model. I have 2 of those. I just recently picked up a second one. I bought this one the other day at a yard sale for $20. Did a video on it. The dang thing fired up on the first pull. I put fuel in it. Fantastic machine. This is kind of the feature of this video, so stick around. The one next to it's probably from the 80s, EM600. It's got a little more modern look to it. Pretty nice little generator. This one doesn't currently run. It'll be a future video. We've got to get into that and get it going. Moving on to the 90s, the EX350, the first inverter generator. Very light, 2-stroke, but very small. I mean, it isn't going to do much, but it's pretty cool. I got a story about that. I got a video about that. Go back and find it if you want the history. And then on the right, the more modern, which you can still buy today, the EU1000. Those are my workhorse generators in my mobile DJ business. I can use 2 or 3 of them at a time, depending on the setup and what kind of venue I am operating in. Outdoor events and stuff is what I specialize in. And I own 4 of those. And then I have a couple of EU2000s. I have an EU3000 IS. I have an EU3000 Handy and an EU7000 brand new Bluetooth generator. Hasn't got its first hour on it yet. Bought that when I retired, about a year before I retired from the company I worked for, because I was able to purchase through the company and got a good deal on it. All of these generators have something in common. They have, let's just focus in over here, the ability to charge 12-volt DC. You see on these earlier generators that they actually have a little deal to block off, so you can only use either the AC or the DC at a time. I believe I was actually researching the manual this morning and went on the Facebook groups forums to ask for sure. But I believe all Honda generators that you have to use the AC and DC separately. You can't use them simultaneously. I think they use the same coils, the windings inside, to produce the power to power the inverter as they do for the 12 volts. So you can't use them both. You could exceed its capacity, so let's not use them at the same time. I am building, now we're going to venture off here for a second. I am building this 1955 Kushman. We're going to call it a racetrack pit area vehicle. It is going to have this canopy looking device on the top. You can see I've got some rough framing in place. That's going to house tools. There's going to be a draw out drawer from the rear. Drop the tailgate, you pull a drawer out, and there's going to be tools and such, like they'll be sorted in boxes like these socket sets and such that I have stashed up here. I've been picking up things, there's some a soldering gun, for example. Everything is going to be in boxes in this pull-out drawer. Then there'll be a deck, and then there'll be a covered area, and these are going to open up. There's going to be doors that open up on all 3 sides, left, right, and the rear, and then a workbench that goes down on both sides, so you can work out of there. Inside of here, inside of this canopy, if you will, that I'm going to custom build, it's going to be things like that air compressor. this retractable power cord and light, and a retractable air hose reel, which I hope to pick that up today. Everything I've got has a story and a price. The light I bought recently at a yard sale for $5. The air compressor, it's a Porter cable, 150 psi. Still got the price tag on it. Picked it up at a yard sale for $10. I am thrifty. Some people call me cheap. I am thrifty. So you'll be able to run over to my little vehicle here, and the sides will be open. If somebody needs something or whatever, oh yeah, I'm going to have a floor jack that's going in a like something you would stand on back here, okay? And then a floor jack's going to fit underneath that. Be some handles on top to hang on to, so a couple people could jump on the back, go for a little ride. We could pack a tire or two on that rack, maybe a couple gas cans. It's going to be a very useful pit area vehicle. Do I need it for all of that? No, but I want to build it for all of that. So how am I going to power this stuff? Well, Honda EU series generator would be a logical answer for that. You could run a really nice battery charger. You could power things and so forth. I'm not sure if that 1,000 watt would be quite enough for that air compressor, so I probably have to step up to a 2,000 watt. Okay, retail on a new 2,000 watt generator is $1,200. Of course, you know that. And I have two of them, but I'm not dedicating one of those to this vehicle. Now, would be nice to have a bigger generator even than that. On the other hand, I have to watch for weight. This vehicle was rated to haul 1,000 pounds, and if that includes me, then we're in a 770 pound range is what I got left. It's going to be a struggle to keep the weight down with as much as I really want to put in that thing. And I want to be able to leave this out and open and so forth, and I don't want to risk somebody stealing something that is of great value. So here's what I've decided to do. This generator on the left, this EM400, I bought it at a yard sale for $20 and brought the thing home, and it runs great. Told you we'd be back to this. Could I use this to power up that generator or that air compressor? No. Not as is. This generator is not big enough to start that compressor. It would just way too small. What if I use this just to charge battery when I needed to and run everything on an inverter? Now we're cooking. So I picked these up at yard sales. I have a ton of them. Okay. I have piles of these things. This is a Hart interface. It's a 1,000 watt rated, 2,000 watt surge rated inverter. It's not a pure sine wave or anything like that. I'm not running sensitive electronics in this. We are running lights and battery chargers and things. I say battery chargers that some race car might need a power for an hour to top off the battery in a race car or something. A lot of them don't run charge systems. So anyway, this one's rated, again, 1,000 watts and 2,000 watts of peak power. This would run the air compressor. All I need is a good battery. Well, like this one. So that Bimart Deep Cycle right there, Group 27, I can't remember the amp hour rating on something like that, 130-ish amp hour. If I had that battery topped off at the beginning of my day at the racetrack, I don't think I could run it dead if I wanted to, but I also want to run a bunch of lights and so forth on this. So I want everything to be well lit in the 12 volt DC lighting. I want it to have area lighting within the canopy, and clearance lights and all that stuff. This vehicle, I want to leave it original as possible, and it doesn't have anything for a charging system. So I'm going to separate what starts the engine and leave that separate. And then all the lighting associated with this vehicle is going to run off of a battery. Going back to now, what I really want to do is just charge a battery. Even if I'm driving this thing, I don't know if I'll ever be able to make it road legal or not, whether I'm towing it to the track or running it from the track to my house on the streets. It would be nice to be able to charge the battery, that big 12 volt battery, with something. Can I use this 12 volt DC outlet? So that's what I started thinking about. Could I run a battery charger off of the AC side? Well, a small one, yes you could, but you can't go buy a nice big battery charger like this one. I have 3 of these. They're in my electric city car. This is I believe I looked this up, it's like almost 600 watts. Well, this little guy is rated at 300 watts. So this is twice as big as would run on that. I could run a little battery charger on it, like a 3 or 4 amp, but this is rated on the DC side for 8 amps. Why can't I use it? Well, because it's not regulated. It is a 12 volt. It actually is probably, and we'll fire it up and we'll test it. It probably is running around 18 or 20 volts with no connection, no battery connection. And it puts out 8 point something amps all the time, no matter how charged your battery is or isn't. It's going to put it out. So you could ruin your battery. You could cook the battery because it's just going to keep on trucking. It has no idea how charged the battery is you just connected it to. So what if you could change that? What if you could regulate that? And the thing it's no different from this generator, unregulated 12 volt output, to the 80s, this generator, no regulated 12 volt output, to the 90s, no regulated 12 volt output, to what you can buy today. This has a 12 volt charge port gizmo plug on it, and it is good for about 8 amps battery charging only. And if you've never seen, this is the cord that this is actually the cord that came with the EX350. So it plugs in like this, and then you hook that up to your battery. Okay, we're actually going to build a cord for that EM400 in this video today, but this is how that works. It's not going to fall. This is how that works. Still unregulated. So it's not a great idea for me to use that unless I really watch it carefully. And if you can watch it carefully, you can kind of be okay. But what if you wanted to let that generator run while you were gone? When we had an off-grid cabin, and I had like the 72 Honda EM400 I was mentioning earlier, and I would just literally put a quart of gas in it and just let it run all the time, running a battery charger on the AC side, a small battery charger. We would just let it run out of gas. We would just shut the door, walk away, and let it just run itself out of gas. We put gas in it the next day, fire it back up again. That's how we did it. Wouldn't it be nice to just start it up and walk away, let it do its thing, and know that you're not going to hurt your battery? So there's the idea. Let me show you what I am going to try in this video. This is what I call my solar shed. As a prepper, I just kind of wanted one place that, you know, if shit ever hit the fan kind of deal, I could pull whatever's in here out of there, and we could have a spot where there was power enough to charge phones and whatever. It's just something like this truckster that I wanted to build. So I did, and I have a 100 watt solar panel up on the roof. It charges one battery, and I'll show you on the inside. But the thing it is about a solar panel, it is unregulated power. In fact, if you disconnected it from a battery and you put a meter on it, it is going to put out, I don't know, around 18 or 20 volts, and it'll put out as much current as the sun will allow. It isn't smart enough to back that off or to change what it does. The brighter the sun, the more it's going to put out. It is unregulated. Do you see a parallel between that solar panel and those generators? So we were in my messy shed, and if I turn on my 12 volt lights, little light fixtures that I built in the ceiling, They're just 1156 12 volt LED tail lights is what they are, that I bought little sockets and made, and I kind of, anyway, is what it is. Now, so here's my charge controller. And what's it do? It takes the unregulated solar panel that would put out 20 volts, let's say, if it wasn't connected to anything, and it would put out as much current as it was rated for, provided it had enough sunshine to do that. What the charge controller does is take that, whatever that voltage is, and reduces it to whatever the battery needs to charge. Okay, so you can see the two little green LEDs. One of them on the top is saying it's charging, and then one on the bottom suggests there is a load, which I turned the lights on, and there is a load on the system. You see we're about 13.1, 13.2 volts. On the right, of course, is a fuse box from the battery, so every circuit that I'm running does have a fuse. Yeah, I was always going to clean all this up, but never did, so there it is. Charge controller, interesting concept. All right, so here is a solar charge controller. It's a little newer than the one I got out in the shed, because that one out there is probably 8 years old. These are inexpensive. You go on Amazon, search around. There's hundreds of them. I don't know that I recommend this one over anything else, but it seemed to work okay on an experiment that I did some time ago. These are rated in current, so we have, remember, the idea now is, instead of hooking a solar panel to this, we're going to hook a generator to it. All right, an unregulated 12 volt output on a generator. We're going to hook that to where the solar panel would go, like the installation I just showed you. Then the battery would connect here, and these two terminals are for a miscellaneous load. You could hook a load right up to here, draw it straight from your solar panel, instead of connecting on the battery posts. So hooking up a generator to here would allow this controller to take whatever voltage that generator is putting out and whatever current that generator is putting out, and correct the voltage and limit the current going to the battery. Pretty cool idea. These are rated in amps. Okay, you can, if you just have a small system, you maybe only need a 10 amp rated controller. Now, the generators are rated for 8 or slightly over 8 amps. I wouldn't go with a 10 amp. I would go something bigger than that. So let's flip this over and find that this is rated for 30 amps. Okay, so we have plenty of headroom. That'll also run 12 or 24 volt. And the maximum photovoltaic voltage is 50 volts. Okay, remember, a solar panel that is not connected to anything but the solar controller will run at something way over the nominal voltage that it is rated at. So yeah, 390 watts at 12 volts, 780 watts at 24 volts. Okay, now the experiment, right? I'll show you again the cord for the 12 volt. We're going to get ready to hook this up. Looks just like this, and that works for the Honda EU, the Honda EX, and this. Let's see, I got that over in the. Got to go to the DC position, just like that, in this EM600. However, the configuration was different, but it's pretty good. Was different back in the 70s, and this has more of a crow foot, and this isn't going to fit. Okay. Let's make a cord for this. This is the generator I'm going to use. Why? Because I got it at a yard sale for $20. It's already beat up. It's vintage. I got my 1955 Kushman. I got my 1974 Honda generator. I think it looks cool, so we're going with that. But we're going to have to make a 12 volt cord to plug into here so that we can then make it up on the solar controller. Okay, here we go. So I've had this end of an extension cord that had to get repaired due to a damaged spot, and we're going to use this to build our cord out of. It's not that long, but it will work in the end. When I put all the stuff into the truckster, it will work. In the end, after this experiment, I'll hook it to these clamps that were left over from the battery chargers that I put in my city car, because I hardwired those in. I didn't use these clamps, but I saved them because I save everything. I pried this plastic off of this end, and I had cut the wire, so I have this wire here. I will tie those together, put a piece of shrink tube on it, solder these, shrink tube them up, and I'll have clamps. If I decide to use clamps for this cord, I may hardwire it, but I just wanted to show you the idea of making your own cord. Now, you got to get the configuration right, correct? Here we go. So earlier today, I had a look at this. These are actually marked. The positive is on top, the negative is below on the bottom. And I had taken my cord, I cut the ground off of it. Don't need that for this. And I already bent one of these. Okay, do you see that? To fit the top hole. And then we're going to adjust the bottom one. I have built many of these using my alignment pliers. Grab that way down at the bottom. Give it a twist approximately that far. We'll see how close I came. I am going to just widen those out a little bit. Do a little tweak like that. A little tweak like that. And there you go. Now she fits. Okay. I took an ohm meter. Oh, let's do it right here with you watching. So I wanted the black wire to be positive or on top. Okay. So that would be this top prong. And there we go. So that just confirmed that this is the positive, the black is the positive. So we're going to hook up this pigtail to the controller with the black being positive. Okay. Okay, we got that connected. Now then, we need to set up the experiment. Okay, we're going to use this little guy. This is another yard sale find, believe it or not. I got this little, I think it's 400 watt rated. Let's look. 400 watt. Okay. I got this at a yard sale the other day for $1. Did I need it? No, it was $1. I don't know. I'm a hoarder. No, I'm not. I'm a collector. All right. Let me go grab a little battery and let me start setting up the rest of the experiment where we connect the generator to the charge controller. We connect the charge controller to a battery, and we're going to use this inverter to put a load on the battery. Okay. We're going to set up the whole thing in small scale. I'll be back. All right, I got the setup done. It is wired. I got a really bad lawn tractor battery. I have the little inverter hooked up to it. I have a little extension cord plugged into it to a box fan. The box fan not currently running because the battery is so bad. We're already down to 11.7 volts. Probably a dead cell in that battery, and that's all right for this experiment. We're just going to see if it will charge. You can see I've only got 2 bars on the battery meter on my solar controller. Okay, so all we need to do now is plug the generator in, fire it up, And let's see if we can charge that battery through a 1974 Honda EM400 unregulated 12-volt output to a solar charge controller. I did run the generator enough to warm it up so that the choke wouldn't be on. Never actually tested the 12-volt output on that generator. I guess now's a good time. Volt DC. Maybe it doesn't work. Told you I had another one. It does have glass fuses in them for the DC side, so this one is working. So what's happening is this thing will allow it to charge, and it'll turn it on and off. At least it was. We might have blown this fuse. Yeah, we have. Alright, so the old generators didn't like that charge controller, and I was cycling it on and off, and I think we blew the fuse in each one of them. So the one worked for a little while, but that was it. So we are now experimenting with the EU1000 to see if the concept is good, just with a more modern generator. And this appears to be functioning fine. So a little twist to our experiment, but we are now powering up the solar charge controller, and again, this is a junk battery, and I'm now going to turn on the fan, which should take a load from here, because again, we have the inverter powered up, still on, running on this little 8-year-old lawn tractor battery. At some point, this charge controller, if we don't have a load on it, will say that the battery is fully charged, and it will shut down the charge, okay? So the fan is now on, so we actually have a load on that inverter. And that junk battery saying, yeah, it's hurting me. Which is fine, that's part of this experiment. So this little inverter doesn't even have an on-off switch on it. So for the next experiment, let's disconnect it and see if it'll take this battery up to 100% and then shut the charge off. So we should see that voltage climb now. It should be just charging. Generator's happier without the load. I think it will run to the point where it just shuts off the solar, and I think we'll see that. Interesting that the generator runs quicker now. I wonder why. Overall, I'm not happy with the experiment. I'm going to take a quick voltage reading on what the generator's putting out. 14.5. Alright, so now I've changed the cord and I'm charging the battery directly. We're just looking at the battery voltage. So this is the unregulated now. Say we're not using the charge controller. Just looking at it as a voltmeter. So we're at 15.4 volts charging. Again, this blue cord that we just built is not connected to the generator anymore. I reconfigured it for the different plug. I just twisted them harder. 15.5 volts. Let's hook a, so this thing, the battery's fairly well charged. Let's hook a battery charger up, a regular smart battery charger up to this battery, and compare the charging voltage to the 15.5 or 15.6 that we're getting now. Alright, we've got the charger connected. I have it on 15 amp mode. Again, the little 400 watt generators are not big enough to run that charger either. And again, I just got the clamps on it. Generator's off. We're just using this as a voltmeter. We're looking to see if the what the voltage difference would be with a regular battery charger. This thing really hasn't kicked up yet though, has it? We're still falling 12.2. That's weird. There, it's kicked on. So 13.6. So that gives you a feel for what a smart battery charger would charge your battery at. And now it says it's 100%. Again, the battery's junk, but we were just using it for this experiment. So we've learned a lot. It didn't end the way I thought it would, but what did we conclude? So the old school generator's 12 volt output is really not happy with what the charge controller was doing to it. So this one is the one we started with, and it probably had a blown fuse when we started, but this one I think blew the fuse during the test. So I'll open those up and put fuses in them. And then we grabbed the EU1000, which was more suited, I guess, more modern, and wasn't that dissatisfied with the controller. So that is an option to use the charge controller for your generator. You can also get a charge controller that has a spot not only for a solar panel, but for like a wind generator. So you'd actually have two inputs, and this thing could sort that out. So if you wanted to run your modern generator, it looks like that would work. And if you had a solar system already and a controller, look, you might have a spot to land your generator. Don't land it on your solar panel if you already have panels on it, but land it where your wind generator would tie into. So I'll have to rethink about my little setup, and I'll probably do some research on battery chargers and just get one that is small enough to run on the AC side, but as big as I can find. So probably it's going to be in the 4, 5, 6 amps something like that, so that I could run this $20 generator and not that, you know, $900 generator, and just dedicate this to this machine, and it would just stay in there all the time. So that's for me to figure out with my little project going forward. This has been the experiment that I wanted to make. I needed to answer those questions, and we did. And I hope you gained some information out of this, especially if you're going camping and you wanted to use your generator to charge batteries. If you want to use your generator to charge batteries, I recommend a battery charger for that. But if you wanted to do something a little weird like I just did, on your older generators, not an option. It looks like on the more modern generators probably is an option, especially if you already have a charge controller. But then again, these are like $15. They're not expensive. You could do that. But modern day battery chargers, this one I got on sale at Harbor Freight, was $52. I like it a lot. The downside is you have to hit buttons. So if you were to build it into something, and like your RV, and you plugged your RV in, you then have to remember to go in and hit buttons, or you know, it may not do stuff. So it may sit there, you think you're charging and you're not. So something to think about. All right, guys, that'll conclude this test. Guys, thanks for watching. Appreciate the comments. Lots of comments, please. And we'll catch you guys on the next video. Please give me a thumbs up on the way out. Right, a little bonus footage. I got the fuses replaced in these. So I wanted to see what the charge voltage and current is. I lost the fuse. And what I was getting, I'll shut that off. What I was getting was about 15.5 or 16 volts and about 4.5 amps. Okay, I may have lost the fuse again. It just quit again. Anyway, that's what we got. I probably should have been using this junk battery because it's probably maybe even shorting out inside or something that's causing my issue. But anyway, so around 15.5 volts charging, about 4.5 amps from my DC outlet on the old EM400. Okay, that's what we got. That's what we are putting in a battery, and that gives me the information that I wanted to continue this video, little bonus footage, so that I know if I decide to run this generator and just connect it straight to the battery, what it's going to do to the battery. If I limit how long I use it, still fine. That's what they were designed for. I'm also having a small connection issue with this cord that I made, so got a couple little things to sort out. But anyway, she was working good. We'll talk to you guys on the next video. All right, I'm trying to decide, this is bonus round number 2, trying to decide what to do for generator for my truckster. And what I questioned myself is, what have I done with this? I'm like, nothing. I bought it, it was on Marketplace. I think it was $50, and I rushed over and got it, and I threw it on a shelf, and there it's been. I don't remember doing anything with it. I assumed it didn't work and just put it away, and there it sat. And so I just put some gas in it and some Barrowman, and it just fired right up. Now it won't. Now it won't. Now it doesn't run. I had it running. Bang. I think there's something up with the ignition or the on-off switch. Anyway, I wiggled it and it started. So anyway, I have this to do. I have this to deal with. I have this as an option. And it's a little more power, so this is probably the one that I'll use, and then decide what to do with the twins over here later. So that will be the plan. All right, the real end of the video. Thanks, guys. Later on.